Welcome, everybody, to the first inaugural DIY Gadget Lab. This is actually a competition. And so the people up here who have screwed, taped, glued, sewn, bloodied their fingers to put their projects together, we're actually competing for your votes. There were some rules, or at least I understood there were rules. And one I understood was that there would be a limit of 8 LEDs per project. And I think we would have had to disqualify a couple of people, except that the remaining people only have 5-minute presentations, and we had to fill the 45 minutes. So we're going to keep them on. Each presenter has 20 slides and 20 seconds per slide. So it's going to be a really rapid-fire presentation of our DIY projects. And we encourage all of you at the end of each presentation to show your appreciation by clapping, yelling, high fives, whatever you think the design merits.
Okay, let's get going. Starting off, I am the content director for the conferences and and the show floor theatre, and I seem to have had a lapse of judgment over this. And I've got a confession to make. This is not my DIY project. It's an inspirational one I wanted to bring you. So bear that in mind as I go through the next 3 minutes of torture. These are personal computers from the 1980s. Kids learned how to program on these. It's the Acorn, BBC Micro from England, Spectrum from England, the Atari from the US, and the VIC-20. I personally had a VIC-20. They were making $9,000 a day at $300. Fast forward to 2006. This is the start of the project I'm going to talk about, the $35 computer, the Raspberry Pi. This was put together by a bloke called Evan Upton in Cambridge. He's part of the Cambridge computer team. So we got together with a few friends, and they were really concerned that students were coming to them with an inability to do computer programming, although they were coming on computer studies courses. This was the first iteration of the Raspberry Pi. It had interfaces both ends. It had an LCD on it. It even had a camera on it. I didn't see this model. The first time I got involved was I went to a thing called a transfer summit in the Dreaming Spires of Oxford. The picture on the right is their dining hall, which was the inspiration for the dining hall in Hogwarts and Harry Potter. A very nice place to go for a conference. And these were the sort of things. There was an open source conference. These are the sort of things there. A talking book for Africa developed in the US. Top right is a 3D printer. The bottom two are Arduino boards turned into clothes. But the one in the middle was the second iteration of the Raspberry Pi. And that is the product specification at that sort of stage. It's based on a Broadcom 700 megahertz ARM, and you can read the rest of it. The main thing was Broadcom do not sell chips at 1,000 at a time. They sell them in the millions. But by happy chance, Evan had now joined Broadcom as a product manager. And so they got that board going. These are the sort of things that their partners got up on it. All sorts of programming languages, all sorts of games, just to evaluate what the board could do. Some of them are definitely aimed at kids. And they had a competition for a logo. And after a lot of type voting, this is what came up. It's it's meant to be a buckyball. And so I got to know Evan quite well. He came to the ARM TechCon in October in Santa Clara. Come next year, I'm doing the content for that as well. By coincidence, I was the chairman of the judging panel on the Hardware and Software Awards, and Evan won the Hardware Award. His wife sort of said, was it you or the board who won it? And so they moved into the second phase of production. I put this up because this is a pretty Gerber picture of the layout of the board. This is the board itself. It's come down in size. It's starting to get all the tracks on it. And now here's the fully laid out one. It's the size of a credit card. And these were the boards they were sort of putting into production or semi-production at that stage. As I said, the Raspberry Pi is a foundation, a charity foundation. The whole idea was non-profit. So to raise some money, they put the first 10 on eBay. And the first 10 boards they produced went for prices between £990 and £350 each. They had a few problems. The first productions, they put the wrong Ethernet connector on. They all had to be unsoldered and resoldered. But that was fairly easy to fix. When I was talking about coming to this with Evan, he said I was going to buy boards off him to give away, and he said, no problem. Oh, we're signing with a couple of distributors next week. They'll have all the stock. And so what happened was they signed up with RS and Alloyd and Element 14 and Farnell, and they took over on February the 29th, and I've been trying to get some boards ever since, like a lot of other people. But on that day, the interest in Raspberry Pi is shown by the Google Trends. The Raspberry Pi website beat Lady Gaga. So I've got to go now, but the next 6 months will really, there's the only board I've seen working in the US. It's on the Element 14, if you want to go and take a look at it later. That's going around the US in a security van. But the next 6 months, meant to be starting deliveries next month, so will the next 6 months be phenomenal or pie in the sky?
All right, a hand for Nolan.
All right, now I want to hear a lot more cheering after I'm done because, you know, this is some cool stuff. The project I'm going to be talking about is the Pipe Dreams Christmas Tree. This was built by the Spectacular 7 team at Oak Canyon Junior High in Linden, Utah, and they recently won the iGen LED Challenge Contest. I'm Wayne Rust. I was the mentor for the group, and I'm proud of these girls and their great accomplishment. It was designed, built, debugged by Camille, Rachel, Aubrey, Katrina, Melanie, Natalie, and Cassie, the all-girl team. They wanted to show some school spirit, which was kind of the challenge of the theme of the challenge. And so they actually decided to make a Christmas tree that was with LEDs on it and donate it to the Primary Children's Medical Center auction. What we ended up with was a project that had 120 feet of wire, 49 resistors, 44 LEDs, 2 microcontrollers, 12 transistors, 162 solder joints, and 57 holes when we were done. Now, we actually wanted the girls to actually work on this. We wanted this to be a full engineering project. So the girls began by calculating the angles and dimensions of the tree. Using math, each girl, and every one of them determined a different way to actually do the calculations. They determined the proper length of each branch and each, as if it was a puzzle piece. Measuring twice before they were cutting, they went to work cutting out all of the parts in one pass, labeling each part so they could put it into the tree frame as a puzzle piece. Each part was inspected by the quality assurance manager and checked against the measurements they had calculated earlier. It's interesting they only made one mistake, and that during the construction, one of the girls who was labeling the parts actually skipped 7 and went straight on. So when they came back, there was slight confusion when they had 9 branch levels instead of just the 8 they had planned on. Of course, this was quickly fixed, and they went on. Just like any other project, the girls actually found that some things don't actually work perfect the first time. They actually found that they had made the trunk of the tree a little bit too flexible, and that it actually drooped over. But they actually used their engineering skills, went back to work, redesigned it, and came up with a good, stable system. Now, as the project moved along, they wanted to add more and more elements. One being, to sway the tree back and forth, to add music to it, to have lights in sync with the music. Luckily, we kind of held them in a little bit tighter and said, and so that they actually made the project and made it on time. Now, learning about electronics was an important part of this project. They had studied transistor microcontroller tutorials by John Titus, taking lots of notes and asking lots of questions. In fact, when I gave them the first data sheet of the NPN transistor, just to show them where the base collector and emitter was, they actually went through and said, where are the other 9 pages of this? This is just 1 of 10. I gave them to them, they took them home and came back with a lot more questions the next day. These girls took initiative and they actually, one of the other things that they actually found out was that in putting the design together, they had forgot to label which one of the wires went to the anode of the LEDs. So they had 32 LEDs, not knowing which side was which. Well, they quickly actually went through and figured it out with a little bit of initiative using just a battery to determine that. They wanted a lot more than just what we were simply going to do. So they actually went through and learned a little bit about multiplexing. What was interesting is we kind of hinted that multiplexing could be done. They went through and actually said, okay, here's how we think it could be done. Work together as a team and actually came up to be able to do the multiplexing and have exactly what they wanted. They also came up with lots of different sequences for the lights for the trees. This is one of the exciting things, and when I met with them to enter all of the sequences into the computer, I actually found out they had multiple pages with lots of ones and zeros all over the place. I later learned that they had actually been writing these down in other classes and passing them between themselves with notes. Now, this is one particular note that I don't think anybody else in the class would have understood. This is kind of a snapshot of the circuit diagram they put together for the star on top of the tree. And one of the things that you actually learn is you find out things that you never knew were possible. They were actually trying to switch on these two-color LEDs between green and red. Well, they switched them a little too fast, and all of a sudden it turned out yellow. Well, they decided, hey, what else can we do? They actually went through with this piece of code here, as you can see, and they were actually able to come up with five separate colors just from a two-color LED, just by changing the timing sequence. This is something that, given a little bit of upfront code for the girls to do, and then having them take a look at it, and they were able to determine, hey, this is where we want to go and go beyond. With this one, they also found out that debugging the circuit and the code took a lot more time than actually designing it. In fact, they worked together well as a team and were excited and not overwhelmed, and they became excited and weren't too overwhelmed with the project because they were working together as a team. Now, these smiles you see in these pictures weren't just for the camera. These girls actually had fun and were smiling the whole time. Now, even with all their clean code and with as much as they did, you can still see that they actually came up with kind of a bird's nest behind because the wires were too long and they didn't want it to show, so they kind of bundled it up behind the star so that it would actually look pretty from the front. They wanted people to enjoy this. Now, you can actually see from this little demonstration that they actually put just a 7-segment LED, came up with the sequences themselves for how to actually put, words and basically sequences up on the screen. You can actually see they put OCGH rules, the Oak Canyon Junior High, for their project. Now, summarizing, being a mentor for these girls was great. I really enjoyed with the girls and hope to actually do it again. And you can actually go through to see their full project. They won the award last night, and you can see their full project at the igen.eetimes.com. And I was really excited, and we had a great time doing this. Now I want to see some applause.
I think I got to jump in here before we have many more projects that have a lot of LEDs. So this is a real girl project. And my slides have been timed for 15 seconds because with only 8 LEDs, I only have about 4 minutes worth of material instead of 5 or 6. So anyway, I'm Karen Field. I work with UBM Electronics, and my DIY, the LED Fedora project, was inspired by Jerry Ellsworth, who was a speaker here last year at the Embedded Systems Conference, who talked about an LED dress that she had designed. And when I went and looked at the build instructions for it, I realized I had a kind of handicap. And so if you see my degree up there, you'll sort of recognize with the mechanical engineering degree why I was kind of looking for a simpler project. So I'm an example of somebody looking for a super simple project to build up my confidence and begin working with electronics. So I began to explore open source boards and came across kind of a treasure trove of these types of boards at SparkFun. I wound up focusing on the LilyPad Arduino, which is designed and developed by MIT students. And this particular board is really been designed for sewing projects, and it really keeps things simple. It eliminates the need for a power supply. In fact, my version that I picked was the simple board. It's controlled by an Atmel 28 8-bit controller and runs about $19.95. Here's my full bill of materials. I did throw in the upcycled diaphanous scarf, thinking that that would kind of make up for sewing errors on the hat, but I wound up with a $40 bill of materials. Here's a close-up look at the lily pad, which has 6 pins. It's connected to a basic breakout board, which allows the lily pad to talk to my Mac Pro. And the lily pad's pretty small, about 2 inches. So far, so good, but as you can see here, I wanted to make sure that it was working before I started any sewing, and late into the night I was still having trouble trying to get it to recognize the USB driver, and so it was time to call in the extra resources. I was getting errors in compiling. When it wouldn't recognize the USB port, I thought, well, maybe it'll recognize something else, and wound up seeing that didn't work either. So out of desperation, I called in my husband, and he has a shirt that says, "I'm not your personal help desk," but I think that many of you guys and girls out there can maybe appreciate when you're called in, when people are in trouble. But I'm happy to say in the end I discovered instructions on how to fix it, and I found it in a forum post that had 26,000 views. So it was really gratifying to know that there were other people having the problem. So anyway, here's me now beginning the sewing part of the project. I'm using a conductive thread, and conductive thread has, which is either a silver or a steel with fiber, has the tendency to fray. So super frustrating to try to get the thread into the needle. But here I am attacking the hat, first by reaching into the hat to sew the lily pad down on the inside of the hat. And the lily pad works primarily in flat planes, so you need a flat surface to sew it to. But I was finding out that starting from the inside of the hat wasn't exactly the wisest choice. Then I got the lily pad down, and I now began stitching the positive to the positive on an LED, but actually, if you studied this photo, you'd realize I was sewing it on the wrong side. So this is proof here that not only sweat, but blood went into this project. This was me pricking my finger and then realizing I should turn the hat the other way so I'm not reaching in trying to sew. So now here's the hat the right side out. What I realized, though, you should always diagram your project before you start, because I realized that I had laid down the first traces, which can't cross each other, but now had all the LEDs clustered on the back side of the hat. So I guess I could just turn this way and present to you. But anyway, the cool thing is I got it all sewed. It works. I downloaded a snippet of code from the internet. The Arduino language is sort of a cross between C++ and Java. So I guess the end of the story is I had a finished product. I built up my confidence. I will be back next time with a cool project. So.
I'm Rich Quinnell, the editor-in-chief of Microcontroller Central. We're a new website we launched in January. If you haven't found us yet, look us up. It's a place to come and talk about all things microcontroller. We do news, but we're not in EE Times. We talk about design, but we're not in EDN. We're more like a kind of a country club for those who like microcontrollers to hang out, talk about, whatever comes up. This all started because one of my posters sent me an animated GIF file with something he had done using a TI development board. It spells out I Heart MCC for Microcontroller Central. He sent me that on Valentine's Day. Wasn't that sweet? So I was intrigued. I thought, I'd like to do that. And I told my boss, I'd like to do that. And about 2 weeks ago, I got a call saying, hey, you're signed up for this Design West, and we have a deadline coming up, and we need your slides. So never talk to your boss about anything. Nonetheless, I decided to rise to the challenge. I got myself one of the boards and tested it out. And as you can see, the software the guy sent me actually continuously displays the message, and so it comes out backwards when you wave it the wrong direction. Also, that little firefly you see there, that's the power on board, and I was told I only had 8 LEDs, so I had to do something about that. This is the TFRAM experimenters board. This is what the design is actually based on. You can see in the circle, that's the power on light that gives me the firefly effect, and immediately to the left is where all the LEDs that I'm allowed to use are. So I solved the firefly problem. Okay, I'm on a roll now with my engineering, right? One problem solved, 16 more to go. So I marshaled all of my electronic test equipment that I had at home. Well, soldering iron really isn't test equipment, but I had to have something else in there. And I looked at all the building supplies that I had available for my electronic system and got to work. So the first thing I needed was, rather than hold a little board in my hand, I needed a hand to actually wave the board around in. So using my own hand as a template, I cut myself a hand. I only cut the wooden hand, by the way. And I wanted a wrist for my hand, so I used some of that elaborate building materials that I showed you to cut myself a little wrist segment and began to assemble it. I routed out a place to put the little board. I fabricated a holding plate out of a junction box because it already had a pre-drilled hole for that conduit cable, and I didn't have a drill big enough for steel, so I made a little handle, a place for an on-off switch, the other attachment to the end of the wrist, and the very first thing I discovered is once I had everything mounted in the board, it was too heavy for that cable. So the first design thing I had to get rid of was my wrist on my assignment. Now, I'm sure you guys have never run into the same situation I had, right? Too short a time frame, inadequate materials, overly ambitious design goals, but that's what I faced. Now, one of my plans was to have the board mounted in such a way that the lights would show through the hand and you wouldn't actually see the board. Unfortunately, they're too far back behind the wood and you have an extremely narrow field of view. So that wasn't going to work. Next thing I decided to try was using a light pipe in the form of a piece of glass that would then bring the LED equivalent image to the front, which is fine, except as you can see from the shape of that, I didn't have glass cutting materials either. So that wasn't going to work. Next, I confronted the fact that I do not know C, and I had never used the development tools before. Fortunately, the folks at Texas Instruments were able to help me, as was the fellow who gave the design to me originally, and I managed to get past that. So I began working, trying to experiment with the board to learn about how to trigger it so that it gave me a stable message. The FRAM board has an accelerometer on it. Not the best thing for triggering motion detection, but at least it will detect motion if you're clever about it. And you can see the typical programmer's lunch sitting down there next to the machine. I did some experiments after quite a bit of effort to get the accelerometer to give me data. The x-axis, you can see when you point it up, and when you point it, that's the y-axis. You can see when you point it up, you get the acceleration of gravity. When you point it down, you get the other. But when you wave it back and forth, you get something that looks completely terrible. The same is true as the y-axis. The y-axis has got the acceleration of gravity, so it's peak when the board is vertical, and it declines when the board goes to either side. But when you wave it really fast, centripetal force takes effect, and you get another ugly-looking pattern. So, turning aside from that for a moment, I wanted to figure out how to put a message in there. Well, you could program these LEDs in binary, which is how the original design was done, but I created myself an Excel spreadsheet that allowed me to put in the pattern that I wanted, and it would give me the decimal values that I could put into my code in order to spell out the message. So, after a great deal of work, I finally got it to give me my hello world message, right? So here is the assembled board, or the assembled hand. You can see I no longer have the mechanical wrist. I painted it red because the LEDs are blue. It gives a nice background contrast. And I used formal black duct tape for the handle. My final design comes up with this. The hello world you've seen, right? But I programmed it with multiple messages. If you are experiencing trouble with traffic, hopefully this says slow down. I can't read it from this end. And if you want to go to your favorite sports game, let's say go Sharks. Okay, I figured Mariners wouldn't do it. I'm from Seattle, but you guys would lynch me if I did that. And then finally, I love MCC. All right. And I have T-shirts up there for you guys if you make enough noise, right?
So my project is the Naked Dalek. Hopefully most people here know what a Dalek is. If you don't, you can follow me on Twitter and Intel Stewart and find out. So Daleks, lots of people make them. The one on the left is made from paper cup. The ones on the right are somewhat more substantial. Mine's is about half size. Half size Dalek is what I've got. But as I say, I've got a Naked Dalek, and this is what's inside it. All right. We've got a mini ITX processor board on top. We've got a 12-volt, 6,000 milliampere battery, laser cut plates, an iRobot Create, an Xbox 360 Connect, and then the USB to serial things. Now, you may look at this and think, wow, he's really cool. He's done some really good work on it. But I bought it, right? I bought it as a kit. But I'm here to show you how you can build it yourself. The software that's running on it is from ROS.org. Now, you may see the PR2 robot on the right. This is my favorite website. Choose your robot, download the distribution. They're all pre-built for all of these robots. They all run robotic operating system. It's a really great place. There are multiple distributors. You can see here, Willow Garage are the guys who originally did the ROS. They're over there on the left. ClearPath Robotics is where I bought mine. iHeart Engineering, or iHeart Robotics, I think, Engineering down there. And then turtlebot.eu. And this is the variations in the kits. You can buy them. This is the mini ITX board that I added to it. I work at Intel. I've got access to mini ITX boards. Surprise, surprise. I've also got access to Wi-Fi cards and some SSDs, so we stuck that on there. A really big battery, right? And the big battery came because we've got a quadcopter in our booth, and we figured out, okay, just use the same battery. If you want to do it yourself, you can buy all the pieces, right? This is from the iHeart Robotics site. They've even got the Eagle CAD files. You can build your own files. They've got tutorials on there for building the little power adapter that you need to connect up the Xbox 360. It's sort of USB, but it needs a 12-volt supply. Imperial Dalek, that's what I'm building. The plans I got were full size. I've created the Visio files that are half size. I'll post them. If anybody wants to repeat this, you can go out there, just build yourself a template. It fits neatly on an 11 by 17 sheet, and you can get that together. Now, I'm not very good at, I'm as bad as Rich at the mechanical stuff, so I'm going to make a punk Dalek, a cyberpunk Dalek, like the one in the picture on the left, but just to give you an example, that's what I built for Halloween, the cyberpunk thing there. And there is a USB camera behind that thing. So this is what I've built, really. I've got, you see there, the Intel poster that we sacrificed to build the thing. So you can see there the Dalek panel with the holes cut in it. Basically, I routed it out with a router. I've got a router that will cut some little holes in it. You need a Dalek voice, right? This is how you get the Dalek voice. There's the Nyquist algorithm that you run through Audacity. You can get the Dalek voice. We've got the Dalek voice here as well, so we'll play that. I'm going to get that right now. This slide's not changing. Oh, there it is. Okay, build your own system. Right, or the topless Roomba. Right? That's my Roomba. I took the top off. Right, hidden underneath there is the diagnostic port. If you buy the iRobot Create, it's nicely accessible, but every Roomba built since 2005 has got that port. It's a little serial port. You steal the little 7-pin or the 8-pin connector from a Mac keyboard, and it all plugs in there. You need 3 pins. Finding a serial port in your laptop's not easy these days, so USB to Bluetooth, USB to serial, or the Roomba Bluetooth adapter, the Rootooth. The files for building the plates, they're all open source. You can go to Pinocchio.com, get the SVG files, print it out, cut it with a hacksaw, choose a color of acrylic. They'll laser cut it for you and ship it over to you. They're a really great site. I've not quite bought anything from them, but I'm really, really tempted. So we've got an Xbox Connect on there. You see in the bottom left, that's me with the infrared. I've got an infrared camera at home. So there's an array of infrared dots. That's my dog, Maisie. That's my old Roomba. And that's what the robot sees, right? The little 3D colored thing. So you can see the little red dots. That's Willow Garage of the things. These bullets are actually batteries. Right? They're the weapons, because every Dalek needs a weapon. And luckily, I happen to have a piece of acrylic, actually glass crystal, that I won last night. And this is what's going to be the weapon. So where's the camera? We should be able to blind most of the cameras and most everybody here, because this is a 5-watt LED system. So this is what's going to be the thing. Thank you very much. If you want to find out how it goes, follow me on DevBoard. Oh. Now, that wasn't real applause. What you really got to do is applaud properly with the Dalek.
Applaud now. Applaud now. Applaud now. Applaud now. Applaud now.
What anybody will do for applause.
I'm a bit short. I have many disadvantages. One of them is that I'm short. The other one is that I'm actually not an engineer in any way, shape, or form. And the other one is that I don't have a cool robot or a weapon system. What I do have, though, is a really cool tutorial for making your very own funky EMF headphones, which I'm wearing, which means that I can't actually hear anyone right now. So when you applaud for me at the end, it's going to have to be really loud. Can tell. So what I decided to do was to make these funky EMF headphones, and what I needed for that was the following bill of materials up here. So most important of all, there was fluff, which actually feels really odd. Like you can buy a whole bag of it and spend ages sort of pushing your hands into it and going, ooh, ooh, ooh. And then what else? We got some really tasteful pink zebra fabric there. We got some cheap headphones that I just got off the rack in Target for about $5. I got a really plain headband, some scissors, some faux fur circles, a glue gun, which is really fun. I really advise anyone who hasn't used a glue gun to use one. It's really a joy. A solder and a soldering iron, and wire cutters and some wire strippers, and a couple of PCB boards there because they just make everything a little bit more earmuffy. So what I've done there is, first of all, I've taken my plain headband and I've decorated it really tastefully with my pink zebra print. Obviously, you can feel free to use whichever fabric you want. If pink zebra print is not your thing, if you don't feel confident enough to pull it off, feel free to use leopard print or something else. And then, so what I've done is I've taken these really unattractive $5 headphones that I got from Target. And the next part, which was really the most fun part, was to like actually smash them up and break them down and rip out those speakers from inside. So really sort of just do like a hack job on them. Pull out those speakers, and once you've nicely Instagrammed the photo, which is, you know, a must in this day and age, you then grab your wire cutters and you cut off the wire 3 inches below each speaker, and you strip off 1 inch of the insulation. So as you can see, it's done for you there, all nice and neat. And what you see when you take off that insulation is that there's 2 wires inside. There's the one copper one, and the other one is red or green. And you separate those 2 internal wires apart. And what they've got on them is this actually kind of transparent coating that, unless you remove it, you're not going to be able to do very much with it. So you strip off the translucent coating with a bit of a utility knife, which basically just gives you an excuse to use a utility knife, which is always fun. And then, so what you do is you've stripped off that coating, and then you tin the ends. So that tinning the ends basically means just making it flat. It's just a fancy way of saying making it flat at the end. And then you get to solder or solder. I'm British, and I say solder because it has an L in there, but apparently, according to Americans, it's solder. So I'm just going to say it like really fast, and hopefully no one will notice I'm saying it wrong. So now it's time to solder, and you plug in your soldering iron. And what I was quite surprised at, as a non-engineer myself, is that these things actually get really hot and can burn off your fingertips. Who knew? So now if I commit a master crime, the FBI will never know who I am, which is always an advantage. So what I did was I basically soldered the speaker wires to the plug connectors, like so. And then what I did was I removed the plastic housing of the jack, slipped the plastic housing over the second set of wires, and soldered those wires to the jack. like so. And then comes the fun part. Then you take your speakers and you put them in the middle of your faux fur circles here, and with the plug facing towards the bottom of each circle. And then you sew the speaker and the plug onto the fabric. Now, that is all easier said than done, especially if your sewing skills are like mine, which are really naff. So my grandmother was actually a dressmaker. I thought that perhaps sewing would be some sort of a genetic trait that she would pass on to me. But alas, no. Along with all my other disadvantages, sewing is also bottom of my talent list. So anyway, we managed to get the speakers onto the middle of the faux fur circles, and I managed to sew on that PCB board just to give it that little bit of extra support there. And they ended up looking like this, or I prefer the Groucho Marx look, which was this. See, it's all a lot more jovial like that. What I then did was, obviously, because you've only got half of the circle that way, so then you have to grab your other bit of faux fur and sew it on to the other side. So again, more sewing, more needless pain and embarrassment and degradation as everyone goes, God, those are your sewing skills? Those are awful. Don't give up your day job, Sylvie. So you sew up the second side of those circles and you leave about an inch so that you can then stick in your stuffing into the gap, which is actually a really fun part. I kept overstuffing mine and then having to take stuffing out. But you get these really nice big puffy headphones. And then what you get to do, which is really fun, is you get to plug in your glue gun, which also gets very hot like the soldering iron. And you then glue the nicely decorated headband into your earmuff, onto your PCB board. And once you've done that, and it's all nice and sticky, and then you've made yourself some spun sugar type glue with the rest of the glue that comes off the glue gun. Once you've done that, you can then sew that gap closed and then just sew it up all nicely. Et voila, you have your funky customized stereo earmuffs, which are then complete, and they actually do work. So I'm just going to put these in right now onto my iPod and play myself some music while you all applaud really loudly so that I can actually hear you.
So this is what I normally look like. My name's Adrian. I'm from TI, and I made a helmet from the future. So to set some context, because I know you might not know this, that in the future there will be a band called Daft Punk. But they were fortunate. They were very kind to us. They've actually come back to the present day as two robots in human form. A lot of people think they're just two Frenchmen from present day in their 30s. No, they're actually from the future, and they're really robots. So why did they come back to the present day? Because that was not easy. Well, they had a simple mission for us. They've shown us, they've come to the past to show us how to rock. Simple mission. So to give you a sense of what this sounds like, what the future music sounds like, I'm going to play a clip of that. And while I'd love to play a video of them in it, they are actually never in their videos. So this is just an open community thing that's on YouTube, playing the music. So on to more serious matters. How do you build this thing? Well, underneath this, there's actually a baseball helmet underneath. You can get it from a used, store, secondhand for $5. The shape of it around it is actually just a bunch of pieces of cardboard, and it was put together with Bondo and fiberglass to give it the formal shape. You can get all this stuff at auto parts stores. To paint it, you use what you use to paint everything else. A little bit of primer. This is some chrome paint. Sand it to make it smooth, and you need a whole lot of elbow grease, which you can get from lots of places, including eBay. The materials, excluding electronics, $85, and you might have most of this already in your garage, so it could arguably be free. On the electronic side, underneath it's being run by an MSP430 launchpad from TI, 224 3mm LEDs. The LED drivers are being driven from the circuit here that we had from another DIY project, and an off-the-shelf cell phone charger, so that you can get that on Amazon or at any store for about $30. So here's what the helmets look like. You can see on the helmet on the right, you can see the cardboard, how it's put together, and we put the fiberglass and a little bit of Bondo to hold it into the shape. So this really kind of gives it the structural integrity. Here, the LED matrix is just a 7x32 LED array, and here's how it's placed mechanically before we put the plastic on top of it, so you can't really see the LEDs themselves. This was actually taken out and put in later on, but here it is to show you it was the right shape. On the right, the audio sensors, you can see that they're actually just soda cans. They were cut in half, so that's what gives the ear pieces their shape. So here's the rough bondoed and fiberglass helmet. It's really rough. If we painted this, it would look even worse than it does now. So we had to give it a little bit more of a polished look. Sanding takes a lot of time because if you want it to look shiny, you want it to look smooth, you have to get it completely blemishless. This is no longer shiny, but it's still silver. But if you wanted to get a perfectly chrome surface, this is a really critical component to make that look good. So post-sanding, this is what the helmet looks like. When this was new, when we did this for Halloween a couple months ago, it was really smooth, and the paint was pretty blemishless. But anyway, this is what it looks like after we had done all the sanding on it. So there's one step we forgot to take a picture of. That's the priming and and the painting of the helmet itself. It's not incredibly interesting. It's incredibly toxic. But it is a key component, so I'm sorry, you just have to take my word for it that we did paint it. You can see the final product for the most part, so it actually did happen. The LED driver, as I mentioned before, this is from another project we had already done, so this is a DIY thing. Those 4 big black chips are the LED drivers themselves. The headers in the middle is where an MSC430 launchpad plugs in. In our version, we butchered this board and cut it in 3 components, one that mates with a launchpad, and 2 LED drivers that connect to the array of LEDs along the front. And you can see from the inside how it mounts inside. We could have used the whole disc, but the disc doesn't fit in the entire helmet while someone's head is inside. So either or. So here's what the electronics look like fully assembled outside of the helmet. Here you see by the 7x32 LED matrix array. This is a labor of love. There's no way to do it but other than manually twisting LED pin together and then blue wire them to the LED driver board, which you can see in the bottom of it and launchpad on the far right. If you mount it to the helmet, this is what it looks like inside of here. It's taped to the inside, so right now it's stabbing me in the face. It feels really good. The power wires kind of route to the side along the front with banana clips. Nothing too fancy there. And finally, you see on the kind of the bottom right, you see something glowing with a blue light. This is the off-the-shelf battery charger for a cell phone. So 5 volts come out. There's about 1,100 milliamp hours. So this will last for a while, long enough for you to impress your friends or to go be a DJ for a couple hours, whichever you want. So now we're fully ready to rock. And if you see my version, it's got lots of nicks and dings because it's had several months of intergalactic battle scars. And our friends from the future, Daft Punk, they would be quite proud of us. So thanks.
Thank you, Adrian. Well, we are really running out of time here, and I have to say, I think everybody was just fantastic as an audience here. It's going to be really hard to figure out how to give away the prizes. Colin, what do we do with the...
I'm going to do mine scientifically. We've got 3 Raspberry Pis, $35 computers aimed at children for programming. Who would want one? Everyone over 30, put your hands down. Everyone over 30, put your hands down. Everyone over 25, put your hands down. 25? 26, put your hands up. 27. You, and you. come up afterwards and give me your details.
It's in the mail, right? Yeah.
Can I tell them how I'm going to give mine away?
All right. Okay.
Right here. Come grab them.
Okay, we've got T-shirts here, and Adrian, who was our backup guy, was going to bring some TI dev kits in case the Raspberry Pi didn't pan out. Apparently, we're still waiting for delivery, but we would like to give away 5 kits, 5 TI Beagle bone kits. Raise your hands. Who would like one, and who will do a project that we can present at the next Embedded Systems Conference? All right, I think we got a few remaining hands here. 1, 2, 3,
Dance contest.
4, 5. And so come up and see me. We'll get your cards and get the kits mailed out to you. So thank you so much. I hope you enjoyed it. And a big round for our presenters.
One last quick thing. Stuart, who's got the robot here, he was a bit too embarrassed to say it, but the bit of plastic he was hanging about was the Mentor of the Year award from UBM Electronics, the organizer of the show, which he won last night.
And a special thanks to our sponsor, Allied Electronics.